Another great danger inherent in climate change is the rise in the number of extreme weather events, which will be more frequent and more violent.
Probably the first abrupt phenomena we're going to see are actually the extreme events, those heat waves, intense precipitation leading to floods and that kind of things.
Some of these extreme weather events are directly linked to changes caused by global warming in polar regions. The recent cold wave that struck the center and east of United States in January 2018 has a direct link to the changes that the Arctic is undergoing. That cold wave was one of the harshest ever, with record low temperatures in Dakota of -36 degrees Celsius or snow in Florida, something that hadn't happened in the last 30 years. The fact that the Arctic is warming more rapidly than the middle latitudes, such as the United States, implies that the temperature difference between the Arctic and the middle latitudes is shrinking. As that temperature gap declines, the polar vortex weakens and it becomes wavier, which means that there could be increasingly greater excursions of cold air masses moving southward. Another of the most dreaded consequences of global warming, especially in polar regions, is the progressive and unstoppable acidification of the ocean.
We have two well-known presently ocean acidification processes. One is where the ocean is taking up CO2 from the atmosphere, and this is increasing then the acidity of the water masses. The other increase in acidification may take place if you release large amounts of methane to the ocean. This is coming from the seabed, and then you have oxidation going on. So you convert methane, CH4, to CO2, so you also increase acidification.
It's too soon to estimate how high ocean acidity will be, but what's clear is that it will have a direct impact on every marine life form. For instance, coral reefs are one of the ecosystems most affected by such acidity, so that if it rises above a certain acidity level, they will eventually disappear completely.
Acidification of the ocean will interrupt the food chain. You have particles, microparticles built on carbonate, and carbonate will go into dissolution if you have an increase in the acidification of the ocean water mass. So you change the food chain in the ocean, and this of course will have an effect. We do not know yet how the impact will be, but there certainly will be some consequences. So you will have a change in the supply of food to the higher level ecosystems in the ocean.
For the past few years, it has been well known that there is a silent menace whose real magnitude we cannot estimate yet, and whose consequences for climate change could eventually be catastrophic. We are talking about the thawing of the permafrost.
Permafrost is frozen landmass, frozen soil. So you have particles of sand. Between the sand you have normally water, and when you reach a certain temperature, it becomes a solid, frozen, icy material. And the permafrost can be several hundred meters in thickness.
In the northern hemisphere, the surface of permafrost is immense, covering more than 19 million square kilometers. The key to understand the menace of the thawing that the permafrost implies is in the gases locked inside it, especially one in particular, methane.
Methane is a very aggressive greenhouse gas. It's much more aggressive than CO2. And this methane is stored in the seabed, beneath the ocean and on land in permafrost regions. Enormous quantities of methane hydrate exist on land and offshore.
Well, methane is important in calculations of what's going to happen to global temperature rise and the impacts of that, because it is a more potent greenhouse gas than carbon dioxide. It's shorter lived, so it doesn't stay in the atmosphere for as long as carbon dioxide, but we know it's also many more times more powerful than carbon dioxide.
We see that there are distinct signs of release of gas from the seabed into the ocean and also into the atmosphere. If the release of methane is at a very high level to the atmosphere, that certainly will affect the temperature in the atmosphere.
It will contribute to accelerate the warming itself. It will have other consequences, but at least this one will contribute to accelerate warming.
Nowadays, there are no scientists who can assure how much methane could be released into the atmosphere and how much the temperature could rise because of that gas releasing. But it's supposed to have an extremely serious impact on the global climate system. Another one of the great unknowns that could really threaten our civilization as we know it is in what is known as the Gulf Stream. If there are changes in the Gulf Stream, which provides Europe with a warm climate, the consequences could be dramatic.
The Gulf Stream, popularly called, we call it the North Atlantic Current, which originates from the Gulf of Mexico, is one of these ocean currents that in a way connects the whole globe, and it's taking warm water from the Gulf of Mexico all the way up into the North Atlantic, coming up here outside the coast of Norway, and then gradually entering also the Arctic, where it brings nutrients and relatively warm water into these cold regions. And that's also the reason why the North Atlantic region is much warmer than at the same latitudes if you go west or east. Then you end up in Siberia or in the North America, where you have lower temperatures.
Scientists have found that the temperature of the Earth, the climate of the Earth, is very heavily influenced by the movement of water through the oceans. These huge ocean currents, which move very slowly but over huge areas. If the Gulf currents, an ocean current that warm up the Western Europe climate, could eventually be decelerated because of the fresh water poured into the ocean by the increasingly meltdown of the Greenland ice sheet, that deceleration could modify radically the climate in the northern and western Europe.
We don't have direct evidence of the big current pathways changing yet, but what we do see is increased heat content being brought up primarily with the Gulf Stream.
Recent studies have shown that we may see a slowing down of the thermohaline circulation, which may bring colder conditions. But the actual total shutdown of that Gulf Stream across the Atlantic is considered quite unlikely.
The transport of water has decreased between 15 and 20% in the last 150 years. It hasn't been so weak in the last 150 years. Warm water coming from the Gulf of Mexico reaches a cold saltwater zone in front of Iceland and sinks. The release of the fresh water coming from the thawing is modifying the density of the water, and it no longer sinks so easily, progressively weakening the Gulf current. Some of the drastic temperature changes occurred in only a few decades. It was thought to happen by the freshwater input into the ocean. During the warming, the ice melted, and so the fresh water was poured into the ocean, and the fresh water changed the ocean current. The same mechanisms could happen today if the CO2 increases and a lot of melting takes place. Then, the fresh water could trigger the cold climate for a certain time.
The more fresh water you bring into this Arctic system, it could be from the rivers, it could be from melting glaciers in Greenland, the more fresh water you bring on top, the more difficult it's going to be to produce this deep water. So if there's less deep water production, then there will be a weakening of this large-scale thermohaline circulation.
There have been various studies that suggest that the Gulf Stream might change in the future, as it certainly changed in the prehistoric past. It's really difficult to predict how fast these changes can take place. Such cooling could occur in a few decades, or in the worst case, in a few years.
We don't see strong evidence of this occurring yet. And it's a complex system where you have a mixture of freshwater balance, cooling through ice formation, but also the wind systems that are contributing. So in the end, how this is going to change in the next decades, we don't really have the answer to that.